What is the worst team in the whole NFL, everybody?
Indianapolis Colts.
Kian says the Indianapolis Colts. I second it. Can we get a third, a fourth, and a fifth?
I don't know.
Okay, Wenzel agrees wholeheartedly. All right. So, check it out. Sorry about the video, Algebris. If you're watching this, hopefully you got word from somebody that the video yesterday died and you should watch first hour Algebra 1 from yesterday. Same stuff. Okay, yesterday in class, we did GCF, and we did a bunch of them. And just now, in like full honesty, how did it feel? Thumbs up is, it felt great when we did the two factoring just now. Thumbs down says, felt terrible, I hate it all. Or somewhere in the middle. Okay, so difference of squares, we did one just now. And then we started looking at this idea yesterday. Do you want me to use this idea anymore or no? Okay. So like some people, if you learn to factor with these physical objects in front of you, it helps. And I do have some students, I don't know how none of you guys are those students, but people did learn to do it like that. And it was Jarvis that taught it to do it like that. But maybe it was Jarvis taught it in the 8th grade algebra class. So I don't know. Anyway, we're going to look at perfect square trinomials. And I don't normally do it this way, but we're going to write down some very detailed steps. And I want to stress, as always, do you have to write down everything I do? No. If you don't think you need these steps, you don't have to write them. But somebody who does want them, I'd rather have them and not need them. It's like a coat when you're going out. Okay. When we're looking at this, I would run through the normal list every time. There's no greatest common factor. Bummer. It's not a binomial. Bummer. So we're going to check to see if it's a perfect square trinomial. To check this, it's kind of ugly how we write this, but could we all agree, and you don't have to write this one down again, but we're looking at things of this form, ax squared plus bx plus c. Because I'm going to reference a and b and c while we're doing this. Okay, for step 1, you need to check 2 things. Do you know the square root of whatever ax squared is? And do you know the square root of c, where I'm referencing a, x squared, bx, and c in this? So let's check. And I draw my lines very specific. I drop straight down. Do you guys know the square root of x squared? It is an x. Okay. Do you know the square root of a 1? 1. So right now, if we are just looking at step 1, do we know the square root of the first and the last term? Yeah. Okay. Step 2, we need to check. And here's where it gets weird, and we're just going to have to agree, and hopefully the language here makes sense just as we speak it. But we're going to check. Is, not if, is bx, which in our problem, can you guys tell me what is bx? The middle term. This is bx right here. Is this equal to 2 times whatever we got for part 1, which is square root of ax squared times square root of c. Now, it looks really ugly when we write the general rules, but here's what I'm thinking. Take this, and I'll wait till you guys are done writing, I'm sorry. Everybody seemed okay with x and 1. If you multiply these together, what do you get? 1x. And if you double it, is this right here what we get if we take this times this and double it? Yeah. It's 2x, right? X times 1 is x, and double it, we get 2x. If yes to both of these, then we're almost done. Step 3 is just simply going to be is factored. Write it as factored. Write it as, and we're going to write the really general form with the understanding that the general form is kind of ugly. It is so much easier than these steps make it look, okay? We're going to write it as the following. It is whatever the square root of that first term was. And then we're going to leave an awkward gap here for just a second. We're going to write the square root of the last term. We'll square it. And then this here is the only thing we need. I need to know, do we add or subtract? I'm going to put a note here, and I'm just going to put an arrow, and I'm just going to put a box, because I haven't said if it's plus or minus, right? We are going to use the sign of bx. That's it. So I'm going to get rid of this, a little bit of it, because I was just talking this out. If you already have it written and you don't want to get rid of it, I understand. I'm just going to rewrite the same problem. Now, let's run through these. And I'm going to make you guys, I know you already answered it, but I'm going to make you answer them again. What is this? Do we know the square root of this? So check it out. I'm just writing my x. Do you know the square root of 1? 1. And if we multiply and double it, do we get this? Okay, so I'm going to put my parentheses. We put a squared because it's a perfect square. And what's the sign on this bx term? Positive? Positive. We're done. Now, just to show you that this really does work. And you don't have to FOIL it out, but I know that if I were to actually do x plus 1 squared, it should be this still. Like we're just rewriting the same expression, just in a different form. You do not have to FOIL it out unless you guys want practice foiling, but I'll convince you, I hope. X plus 1 squared literally means x plus 1 times x plus 1. Feel all right? So now we're going to distribute. What's x times x? And x plus 1? What's up?
1x.
Do you see why it's 1x? Do you understand why 1x? What's 5 times 1?
5.
What's 3 times 1? What's x times 1? There it is. Okay, what about this one? X and this last one?
1.
Plus 1. If we clean this up, do you guys agree this very clearly was x squared plus 2x plus 1? We wrote it in its factored form, and we've just distributed to show that, yes, this really was it. Now, there's a bit more going on here that if you want to dive in with the manipulatives, we can, but I'm also okay with just going the purely algebra route. Okay, I legitimately think it's good to do the other part, but that's more of an algebra 1 thing when we're building up the intuition. Okay, let's try another one together. And I'm going to try to pause and resume a bunch so the video's shorter than it needs to be, or than it really is. Here is B. Now, we'll do this one completely together, and then I'll give you 1 or 2 to do on your own. Step 1, and hey, we got a lot of people. Just kidding, we only have 4 people in here. It's tiny, but I bet I can ask 4 questions. Yell quietly. How do we always start factoring?
Find a x squared.
Pause. How do we always begin every factoring problem? I'm looking past my digital board, just so you know. I'm looking at the white one. We check for GCF every time. Is there something that goes into 2, 16, and 32?
No.
So Kian, you said 2 and then you changed your mind. Why did you change your mind? Does it end in a 0, 2, 4, 6, or 8?
Oh, no, it does.
Okay, so if we factor a 2 out, what does it leave behind? And this I'm going to move to somebody else. David or Kian, who wants it?
X squared.
X squared minus what?
16.
Careful, what did we divide out?
8.
8. X plus
16.
16. Have I lost anybody? Try again. Anybody not understand what just happened? Because I get the sneaking suspicion in every single class I've ever taught. When I say that, everybody goes, nope, we're good. And then if I ask a second time, yep, and that's fair. I need to be better with questioning, but I would like you guys to try to be better about speaking up if you don't get it. Like, that's everybody, not just you, just so you know. All right. Okay, the 2, we do not leave it behind. It comes along for the ride. But I'm going to look at this one. Let's just only focus on this piece now, because we've broken it down into smaller pieces. Is there any more GCF?
8 and 16.
Careful. You say 8 and 16. I agree with you that it goes in 8 and 16 have a common factor, but we need one between all 3 of them.
X squared.
Does this one have an x in it?
No.
No, so we can't take an x out of them all. These ones, both an 8 can be taken out of. Does this have a power of, or a factor of, oh my gosh, a multiple of 8? 1 is the only GCF, and here's the new rule. If it's 1, we're just going to say no, because any 2 things you ever give me have a 1 as a common factor. There's nothing else to do. So we're in our trinomials, because it is a trinomial. Very first thing we check for is perfect squares. How do we check for a perfect square trinomial?
Find the square root of ax.
Do you know the square root of our first term?
X.
X. Good. Do you know the square root of the last term?
4.
4. If you multiply these, you get 4x And if you double it, do you get an 8?
Oh yeah.
So we have a perfect square trinomial. Again, if that's not clear, I'm going to undo this here in a second. But if I take this times this and I double it, I get 2 times 4x is what it winds up being. Is that the same as 8x? We are perfect. And all we need to do is just finish writing our factorization. Now, the spacing here looks dumb. There's just no avoiding it because I was trying to really draw it out. I won't forget to put a square here because it's a perfect square trinomial. Last little thing. How do I decide the sign that goes between these? What is the sign of bx? Boom. We're factored. Now, here's the cool connection that I don't think I made with first hour, and I don't want to unplug this because it's going to stop, but I do want to point something out. We have graphed quadratics that look like this, and we have graphed quadratics that look like this. Do we all agree that this was the easier one to graph? And you might not, but what do you think? H vertex form or general form? Which was easier to graph from?
Smaller numbers. So.
So this one, it tells me the vertex. I can see the vertex right here. Can you guys still see the vertex on this? Not 2. Here's H. It's 4, and I'm adding what on the outside?
Okay.
Did I write plus 1?
No.
If I didn't write anything, that must be plus 0. The vertex of this is 4, 0, and I can see that. Now, in either case, if we had to graph this or this, I think that this is easier.
Yeah.
We just, for the first time, saw a way to move from this general form into vertex form. Now, if it's perfect, it'll work every time. Later in this chapter, we'll see that they're not always perfect. Our focus is not graphing. If that doesn't click, that's okay. Here is our complete factored form. All right, one more. And if you're on the road, I want you to try this one. And we're going to get crazy about it. So let's check it. It's actually not going to be that crazy. I want, love it. And I'm just trying to make up nice ones right now. Relatively nice. Yeah, we'll do that. Here we go. We are going to factor, and you, are going to factor 3x cubed minus 6x squared plus 3x. It's bigger than a quadratic, but as long as we all agree, and I just want you all to shout out the answer, I'm going to ask a question. It's going to be, what's the first step of a factoring problem? Okay, pause on 3. What is the first step of a factoring problem? 1, 2, 3. All right, Kian's got it. Yell was taking a drink. What's the first step of every factoring problem?
GCF.
Okay, awesome. David, if I want to start a factoring problem, what do I always begin with?
3.
So you answered the question correctly. You said 3 because you, I think, saw a common factor. GCF is what I was after. I'm good with 3. Okay, I want you guys to do this. Video people who are watching this on the road, pause the video now. You will see a detailed solution in 3, 2, 3, 2, 1. If you don't notice the whole GCF in one step, it's not the end of the world as long as you always keep looking. If we saw a 3 first, reasonable. If you catch yourself doing this and thinking there's nothing else, here's my advice. Do numbers first, and we see a 3 comes out. Now that we factored the 3 out, we keep looking though, and if it has to go in 2 steps, totally good. Is there anything else all 3 terms have?
X.
And what's the least power or the smallest power of x that's here? Even though we don't write it, this is it. Now, I'm going to factor out the least power that they all have. So if I now wanted to factor out an additional x, here's my 3. It's still here. We don't lose it. But now I'm going to factor out an x, and it leaves behind x squared minus 2x plus 1. At this point, here is a factor. That's one of them. Our second factor is this guy, and we always have to keep looking. Do you know the square root of this? Try again. X. And like, you're right, King, because you're thinking 1x. You can say 1x and I'll always allow it, but if you just give me 1, I'm always going to say you're wrong, just so you know. Okay, what's the square root of this? 1. And if you take x times 1 and you multiply them, it's just 1x. If you double it, you get 2. Okay, so let's see. We're almost done. 3x, x, 1, a square. Wenzel, I didn't check closely. Make sure you have your square. What sign goes in between them?
Oh, minus.
Why?
It's 2.
That one. Awesome.
Ben Bay.
Choo-choo train. Cool. Are these relatively easy?
Yep.
Okay. Yell, feeling all right? Cool. Are you really feeling all right?
Kinda.
Is there a part of this where you catch yourself struggling?
Yeah, like how did you get to?
I'm going to write lines. Here's A, B, and C. Which line are we looking at? On line A, how did I get the 2?
Yes.
Do you agree that when we look, if I say what goes into 3, 6, and 3, do you agree a 3 goes into all 3 of those numbers? I divide by 3 or factor out the 3. And if I do this, it's just x cubed, and the 3's out. If you did this, what do you get? And if you do this, what do you get? And there's our 3, 2, and 1. Yep. Cool. All right. Let's bump it up. What's going on over there?
The car.
Okay. Did you guys just see the elephant walk by outside?
No, I'm just like.
All right. Here we go. We're going to take a new approach. Now, not really a new approach. We're going to build it up. If we run through our list, GCFs, we've hit them. Difference of squares, we've hit them. Perfect square trinomials, we've hit them. The next little part of this, I'm going to do it backward than is on that list. We're going to do some examples where we're going to factor by grouping.
That's right.
All right. I am going to be closing the window. Thank you for the heads up, Kian. All right. This one. Here's the big one. Turns out that factoring by grouping, I'm going to be honest, if you can't remember any factoring stuff, this one will work for all of them. Okay. For every single one. Now, given, and we're going to try to write out these steps real quick, and we're going to follow along. And again, if you don't need the steps, it's up to you. But given ax squared plus bx plus c, if we want to factor by grouping, there's a very particular process that we follow. I'm going to make this much simpler. We're going to say step, it's exactly the same as I did last time. Okay, step 1 of a factoring by grouping problem. And I'm going to let you guys help me decide. Do you want me to do like, here's a step and we'll do a problem at the same time, or do you want to see all the steps and then we'll do a problem?
A step with the problem.
Steps with a problem. So here's a step, and then this is going to look silly in our notes, but we'll have example A over here. Okay, so let's give ourselves something that looks like this. And I'm going to start with a very particular value of A to see if we can catch anything. So let's say it's x squared plus 3x. And I'm going to make that bigger. I'm going to make it 13x. Nothing crazy has to change. Plus 30. All right. We have in front of us a quadratic of the form ax squared plus bx plus c. I need your guys' help real quick. We want to write them down. What's a? So careful.
1.
Good.
Yeah. Oh, yeah.
A is 1. It's the number in front of x squared. I'm going to rewrite this so it looks a little better. Plus 13x plus 30, right? Okay. A is 1. What is c?
30. Oh.
C,
30.
Charlie.
30.
Okay. So step 1, if you can identify A is 1 and C is 30, we're golden. We are going to multiply A times C. These are the coefficient of x squared and the constant. Now, I'm going to do the same things over here, and I'm not going to switch color because it's going to be too ugly. There's a 1 right here that we never write. What's 1 times 30? 30. All right. Now, the whole basic idea of factoring, and I'm going to use some fake math words. We take a trinomial, or a trinomial, a thing with 3 terms, and we're going to rewrite it as a 4-nomial. Or there's situations where maybe a 6-nomial or an 8-nomial, it doesn't matter. We're going to write it with an even number of terms. We're going to multiply AC. We just did that. Step 2, we need to find 2 numbers. And I will refer to these as magic numbers. They're not really magic. They just work really nicely. We're going to find 2 numbers whose product, which just means what? Multiply. 2 numbers that multiply to be AC, but sum, they add up, or they sum to B. Not a 6, a B. Now, in our particular problem, I rewrote it so that we'd have a bigger issue. Some of you guys are going to be so fast with mental math. Some of us need a little bit more time. Eventually, we get big numbers that are too much to mental math. So we need to come up with these numbers.
That's how I usually solve.
Yep, so check this out. We do not have to write this every time, but I'm going to write it this time because if you're good at mental math, there's still a chance that you miss something just because you're mental mathing. I want to start at the very beginning. We're going to write a bunch of factors of 30. Eventually, you'll probably only write a couple of them, if more than one. But do you guys agree that 1 times 30 is 30? What do they add up to, though? If you did 1 plus 30, is that 13? No, so give me another number. Does 2 go into 30? 2 times 15. And do these add up to 13? No, but are we closer?
Yes.
Yeah, before it was 31, that's a ways away. Now they add up to 17.
3 and 10.
But the next one would be 3 and 10. What do these add up to?
33.
Careful.
I can see 30.
They multiply to be 30. What do they add up to?
13.
Is that our number?
Yes.
This is it. This is our magic number, or our magic numbers, if you will. Okay, that was step 2. Now, I would always advise, especially with big numbers, start. Does 1 go into it? 1 times what? Does 2? Does 3? Does 4? I would count my way up because eventually we're going to get big numbers. And if you have a systematic way instead of just trying to guess random ones, you won't be repeating and you won't miss any. Okay, step 3. We are going to rewrite the original, and I'm going to, I guess we'll say the original trinomial. Any objection to me just saying trinomial?
No.
As a fournomial. And this is not super formal language using magic numbers. Now, this could be reworded, but I think this one will suffice for us. I'm going to use a little bit of the color differences. I want to change this 13x into something else. So when we rewrite the original, it's still 1x squared plus, now my magic numbers kick in. Instead of 13x, what do we just find were the two things that might work?
3 plus
3x
3x.
plus
10x.
10x. Notice, our magic numbers just replace this middle term, plus 30. Okay, super duper important. These two expressions, where we started, and sorry I'm getting louder, it's just so they can hear. Where we started and the last thing we wrote, that x squared plus 3x plus 10x, they look different. But let's check it out. If I were to combine these like terms, does it give me the same thing that we started with?
Yeah.
Yeah, so it's just a different version of the same thing. Equivalent, but looks different. Okay, for this, a couple things I'm not going to put in the notes. Always include that plus sign. Even if it's a minus, instead of minus 10x, we do plus negative 10x. And there's a reason for this. Always include this sign. Okay, other things. Is it possible that somebody had 10 and 3 instead? It doesn't matter. The numbers, the order that you put them in is irrelevant as long as they're the same numbers. Okay, step 4, and this is really the rest of it. Group two groups of even number. And that sounds silly, of even number. If we have 4 nomial and we want 2 groups, each group better have what? 4 things cut into 2 groups. Each group has,
30.
so let me rephrase that. I wasn't pointing at anything, I was just highlighting everything. If I have 4 objects or terms and I wanted to cut it into 2 groups, each group would have 2. Okay, we're going to group this by introducing some parentheses. Now, I'm going to rewrite it. You probably won't in your notes, but I just want to make sure these steps are very different steps. Okay, I'm going to add a parenthesis right here and right here. Remember the comment that I made about the plus sign. I need a plus sign in between them. If I put my parentheses incorrectly, like this is the correct version, if I'd done this, is it telling me to add them anymore?
No.
It's telling me to multiply it. We don't want to multiply. We want it to be the exact same expression. I've added parentheses that don't really change anything. Everybody cool here?
Yes.
Okay, the next step. We're going to take GCF. Take GCF from each group. Now, there's a little bit more to it, but in the interest of the amount of writing, we're just going to have that. What is the GCF of this very first group? 1 goes into both of them. Anything else?
X.
They both have an x, right? X to the first power is the least power. I'm going to factor out an x. That leaves behind a what?
X.
Plus
What?
X plus
3. Because we didn't factor out the 3, we only factored out the x.
Oh.
Okay, big question. And I'm going to add a little bit more. Take GCF from each group. We must match. And you'll see exactly what I'm talking about here in a second. We have to match. What I mean by that is in my second grouping right here, the 10x plus 30, is there something that we could take out that would leave behind exactly x plus 3? Or even, and you don't really have to think a whole lot about it that way. What's the common factor? 10. If I took a 10 out, what stayed inside?
X plus 3.
Do they match? And by they, I mean, does this grouping match this grouping now?
Yeah.
Okay, this last step, it feels like magic, and you guys have, I'm sure you've done it, but you might not remember why this works. We have 2 identifiable factors at this point. One of my factors was the one that we matched, x plus 3. Can you tell me the other factor? Say it again.
Oh, X plus.
X
Oh.
plus 10.
Oh.
Now, I remember vividly when I learned this, and so much so that I'll even name drop here because I know I'll never watch the video. My math teacher, Mr. Henningsen, was fantastic. I was not a good high school student, but he was awesome to me. And maybe, I don't know. Well, I ran it. Anyway, not the point. This part feels like magic. Can you guys explain to me how we go from here to here and why that's allowed?
You're just multiplying X and 10 into X plus 3.
So check this out. I'm going to rewrite this. Is this the same thing? And you don't have to rewrite this one. Is this the same thing? I've just moved the order.
Yeah.
Okay. If we look at it this way, if we foiled, and I wouldn't write this yellow, anything in here will make it, you can, obviously you can write whatever you want, but if it's in the grass, it's just for thinking. Cool. All right. So check this out. If we were to foil, and I know that like factoring is just the opposite of foiling, but if we were to foil it out, do you guys all draw these lines?
Yeah.
Okay, notice what just happened. We took x and we multiplied it by x plus 3. Like that's what we really did. Do you guys agree with it?
Yeah.
Okay, plus we now take the 10 and we multiply it to what?
X
X
plus 3.
We did the same thing. This is what we just stopped at, and this is the FOIL. Does it really work this? We don't usually write it that way, but is that just what FOIL does? Like I can tell that. It's just this first term times that other one, and this one times the other one. This is equivalent. These are the same thing. We've just rearranged it. That step feels magic when you see it. It felt magic to me for years and years and years until I had to sit down and I actually did that FOIL one time and just realized that, oh, yeah, it works. Okay, we're going to do one more easy one like this. Before doing so, do you guys have questions? Are we going to do an easy one, similar easy one together, or do you want to try one on your own?
The answer is
This is our answer. This is the factorization. Sorry, Winslow, I should have made that clear. All right. I'm going to give you guys a moment to get started with this. I will give you homework this weekend, just so you're aware. It's not going to be a crazy amount, but let's go ahead and do another one like this. Now, I'm going to give us a little easier of a number, and let's see, x. Okay, this time on B, I want you guys to factor, or attempt to, I think you'll get it, 2x squared minus 10x minus 28. If you're watching the video on the road, pause it now, and you will see a detailed walkthrough in 3, 2, 1. When we start this problem, the question came up, why would I do a GCF if we're going to factor by grouping? Most of the time, it's multiple types of grouping combined. So we always check for GCF, multiple types of factoring. I'm always going to check for GCF, no matter if it's a difference of squares, whatever the case is. If we look back at another example that we did, even today, this one was a difference of squares problem. What do we start with though? GCF, every time, because now we just have a simpler thing to deal with. We always will start with GCF. There are there's a little, every once in a while there's a reason not to. We haven't seen it yet. Can we all agree that they don't all have an x? This one does not have an x term. So what can I can't factor out an x, but is there a number that goes into 2 and 10 and 28? Is it 2? Okay, leaves behind x squared minus 5x minus 28.
That's 14.
And this is, just kidding, thank you so much, Kian. You saved the problem. Everybody okay with there? We've just done GCF.
Yeah.
Okay, now I'm going to start my grouping process. The 2 is going to come along for the ride. He won't disappear, but I'm going to look just at this piece. What is the leading coefficient, the number connected to my x squared?
What?
It's a 1. So I'm going to do 1 times, what's C?
14.
Almost.
Negative 14.
Negative 14. Now I'm going to actually move that down a little bit. We'll try it again. And I like my lines curved, so I'm going to do that. Can you guys help me come up with factors of negative 14? And we'll just start. 1 and 14. That's not quite right.
2 negatives, 2 and 7.
So before we get here, one of these needs to be negative. In the end, when I add them up, they add up to a positive or a negative number. So which one should be negative? The bigger 14 needs to be negative. If you add these up, you get negative 5.
No.
So let's kick forward. Does a 2 go into
Yes.
2 times negative 7?
Yep.
What do these add up to?
Negative 5.
Negative 5. Is that what they need to?
Yep.
Yeah.
Now, in this situation, we found our numbers. It took 2 this time. We are going to rewrite my 3-nomial as a 4-nomial. Now, my other factors don't fall, like they don't stay behind. This 2 was written. I'm going to bring it with. Now, I'm going to do my color changing thing. I'm going to write x squared, and then here we have a decision to make. The way we've written it, do you agree that it's plus 2x? And then I made a comment earlier. I'm always going to do plus negative 7x. Now, we will see why I'm crazy about that and why I'm encouraging that all the time. But right now, I've replaced that term.
Why is there an x?
Why is it plus?
So we'll just address it right now. You're asking why I wrote plus negative?
Why is it plus instead of
So if I said, and that's a good question, adding a let me rephrase. Addition and subtraction are really the same. Minusing a number is just adding the negative. Now, the reason that I stress to do this is because if we don't do this, when you go to put your groups, you're naturally going to put a group right here, and then you're going to try to put a group right here. Does that reasonable? So if you disagree with that, that's pretty unique. I think most people will try this. The alternative is they'll try this. But neither of these are right, because now this would be plus 14 if I distribute it back through. To avoid any of that confusion, I like this grouping so long as we realize that subtracting is the same as adding a negative. Now, you could avoid this if one's positive and one's negative by doing the negative 7x first. It doesn't matter which one comes first. Okay, so as long as we remember the plus between them, we're golden. Now, let's keep looking. 2, and I'm going to use brackets just because they look a little nicer when I have parentheses also. Is there something that goes into both of these?
X.
An x goes into x squared and an x goes into 2x. Kian.
Why is there a 2x on the first parentheses?
Because remember, we take these magic numbers, 2 and negative 7, to replace this.
Oh, it's
Sorry, it's this one in this case. Okay, so if we factor out an x, what stays behind?
2.
A little more.
Sorry.
X plus 2. Now, is there anything that I could factor out of the other group to leave behind an x plus 2? Now, this plus sign, I don't need it anymore. I only include this to make sure that we don't all of a sudden think we're multiplying. I'm going to factor out a negative 7x. And if you want to write plus negative 7x, I'm okay with it. Just negative 7, I'm sorry. But now it is not needed anymore. I switched just to calling it minus. If you divided this by negative 7, what stayed in? X.
Plus 2.
Plus 2. Do these match?
Yes.
That is my indication that I'm correct. Our very last step is just being able to write this as factored. So here we go. Back to purple for everything. 2 was there. What is one of my 2 factors inside of these?
X plus 2.
X plus 2? Can you tell me the other one?
X minus 7.
X minus 7. Now, we are at the end of class. I'm not going to give you homework, but I do want to leave you with one parting thought, if you guys can give me like 30 more seconds. Notice, if we forget about the 2 and we only look at this part of the problem, we found the numbers were 2 and negative 7. Check it out. Here's a 2, a positive 2 right here, and an x, negative 7. If we look at the one we did just a second ago, I found the numbers were 3 and 10. We went through this whole grouping process. Notice, here's a positive 3 and a positive 10. There is a shortcut. I even referenced this shortcut on our factoring cheat sheet. If the leading coefficient is 1, we get hooked up like big time. Cool. Since you don't have homework, it means I expect you guys to go cheer on your Raiders at the swim meet tomorrow, 6 p.m. at the pool.
What if you're busy at home?
Then that is justifiable that you won't be there. I'm not going to require you to be there. Swim meet tomorrow, Friday, the 3rd of October at 6 p.m. I've been to the pool during swim meets. It's kind of depressing. Go, because there's not many people that go. Go cheer on your fellow Raiders. You might as well just take your bathing suit and swim afterward too, because swimming's fun and healthy. Later, Raiders.
A lot of cardio.